All right, let's jump right into this explainer. Today, we're unraveling a bit of a detective story, looking at the seemingly arbitrary numbers hard-coded into the very foundation of Bitcoin. Whether you're a longtime observer or just kind of curious about how these digital networks actually tick, you've probably noticed some really specific, rigid numbers defining the whole system. So we're going to explore exactly why the system was built on a foundation of perfect integers and how that one mathematical choice is, right now, actively shaping the future of invisible sub-penny micropayments. So, we've got to begin with a question that so many people ask, but honestly rarely get a satisfying answer to. Why did the creator choose these specific constraints? I mean, why 21 million? Why exactly 8 decimal places? If you browse through early cryptography mailing lists or modern Reddit threads, you'll literally see endless speculation about this. Was 21 million just a lucky guess? Was it meant to mimic the way gold gets harder to mine over time? The network theoretically could have worked with any other set of numbers, as long as everyone agreed on them. So, what was the actual logic here? Well, what's really fascinating is that Satoshi directly acknowledged these numbers were basically an educated guess. In an email back in April 29 to developer Mike Hearn, Nakamoto admitted that setting the supply was a pretty tough choice. Because once the network was running, those core rules, they were set in stone. He wanted to pick a number that would make prices feel similar to existing currencies if it ever became a global standard. And by giving the system 8 decimal places, he ensured there would be plenty of granularity. Plenty of tiny pieces to go around, just in case the price of a single unit ever went sky high. But the real secret? It actually lies in this absolutely massive number, 2.1 quadrillion. Yeah, that's a big one. You see, the 21 million limit is, in a way, an illusion created just for our human brains. Because at the protocol level, Bitcoin doesn't actually exist. The network only understands its foundational atomic unit, which is the Satoshi, and the absolute maximum total supply of the network is exactly 2.1 quadrillion Satoshis. But why that exact number? Well, it all comes down to the literal limits of computer science and database architecture. So here is the absolutely crucial point. A 64-bit computer architecture can flawlessly handle up to 2.1 quadrillion whole units without ever needing to encounter a decimal. Standard financial systems and a lot of programming languages use something called floating point math to calculate fractions, but that is notorious for creating these tiny, annoying rounding errors. And if you're building a trustless, global, immutable ledger, a rounding error is literally fatal. So by restricting the absolute supply to 2.1 quadrillion, the protocol ensures that every single balance fits perfectly inside a standard 64-bit integer. It guarantees the ledger is mathematically exact, down to the last drop, forever. And this perfectly illustrates the reality of the protocol. There are actually no decimals anywhere in the code. Zero. What we call 0.001 BTC is just a human-readable label generated by your wallet software to make it easier for us. Internally, the network simply registers that as 100,000 whole Satoshis. It's a system of perfectly indivisible integers acting as the foundational atoms of the network. Satoshi even noted that if the value of the network grows, we can simply move the decimal point in our user interfaces. We don't ever have to alter the flawless 64-bit engine running underneath it all. Okay, moving into section 1, the Satoshi limit problem. Let's look at how we handle micropayments. This brings us to a really massive mystery. What happens when the network's value skyrockets and a single Satoshi becomes just too expensive for a microtransaction? As we've established, if 1 Satoshi is the absolute protocol limit, we literally cannot split it on the base layer. It's the absolute floor. Trying to force a half Satoshi on-chain would require a highly controversial hard fork. We're talking about a fundamental rewriting of the consensus rules, which experts agree would basically destroy the trust and predictability of the system. So how in the world do we process fractions of a cent, like paying a tiny fraction of a penny to read an article, without completely breaking the system? Well, the ingenious solution was actually outlined by Satoshi over a decade ago: high-frequency transactions. You might know these today as payment channels. Basically, users like Alice and Bob can open a channel to manage thousands of transactions entirely off-chain. They rapidly update their balances back and forth, and they only settle the final net balance on the main ledger when they're completely done. Let's break down exactly how these channels master the sub-Satoshi problem. 2 users open a channel with a standard transaction. But inside that channel, because they are operating in the application layer, they aren't bound by the blockchain's strict integer rules anymore. They can track incredibly fine billing, down to the milli-Satoshi, which is literally 1,000th of a single Satoshi. Imagine being billed a milli-Satoshi for every single byte of data you download. Crazy, right? And because this is all just tracked in the software's memory, it doesn't clog up the base layer at all. When you're finally done, the software just rounds the final tally to the nearest whole Satoshi, closes the channel, and records that perfect integer permanently on the blockchain. Any tiny rounding difference is economically completely irrelevant. But wait, it gets better. There is an even more counterintuitive genius built on top of this, and it's called probabilistic payments. Sometimes even setting up a channel is just too much friction for really quick, dispersed interactions. So researchers have modeled a way to process true sub-Satoshi microtransactions using the pure mathematics at probability. Think of it like this. Imagine you need to pay a 5-cent fee to a server, but the smallest coin you have in your pocket is a $1 bill. In a probabilistic payment system, you hand the server that $1 bill, but you attach a cryptographic lock to it that only has a 1 in 20 chance of actually opening, right? So 19 times out of 20, the transaction fails and no money moves. But 1 time out of 20, the server gets the full dollar. Over a huge volume of transactions, the mathematical expected value perfectly matches that 5-cent price tag. It's brilliant. It allows the network to effectively process sub-Satoshi values without ever dividing a single Satoshi on the actual blockchain. So what you should really take away from all this is a profound shift in how we think about digital scaling. The network's ultimate scalability and its security rely absolutely entirely on preserving the immutable perfection of those 64-bit integers on the base layer. We don't break the atom. Instead, we build flexible, high-frequency, programmable layers right on top of it. Through payment channels and probabilistic math, the friction of micropayments is just being completely erased in the application layer. Leaving you with this to ponder as we wrap up this explainer. The integration of this tech means every device on the internet could eventually have its own payment identity. So if we can reliably stream thousands of a penny between machines, paying for a split second of electricity, a byte of data, or a single API call without ever breaking the base code, what entirely new, invisible, machine-to-machine economies are about to be unlocked? Thanks so much for joining me today, and always keep questioning the math behind the technology we use every single day.